Okay, first we determine the profit function. So we write profit function P of x equals the revenue function minus the cost function. And the revenue function, which is written as R of x, cost function is C of x. Revenue function is basically x times the price demand function. So we write x times of P of x gives revenue function minus the cost function C of x. So let's replace P of x by 82 minus 2x. So therefore this becomes x times of 82 minus 2x, and minus of the cost function is 2x plus 9. So I write down this in brackets 2x plus 9. Let's simplify this to determine the profit function. We distribute this x, so we get 82x minus 2x times x is minus 2x squared, and this is minus 2x minus 9. If we distribute the minus, we can simplify this. We have 82x minus 2x. These two are like terms. So first I write down this negative 2x squared. Then 82x minus 2x is plus 80x, and then minus 9. So this basically represents the profit function P of x. We now determine the number of watts of ice cream needed to be sold to maximize the profit. So basically, we have to maximize the profit. We have to determine the x so that the profit is maximum. So let's consider the profit function P of x. And this equals negative 2x squared plus 80x minus 9. So we are going to maximize this profit. So for that, we have to set up this equation P prime of x equal to 0 and determine the critical point of this profit function. That is, we have to find x after setting up this equation to 0. So let's find the first derivative of the profit function. So we differentiate both sides with respect to x. And so therefore, the derivative of negative 2x is negative 4x when we use the power rule, because we have negative 2 times the derivative of x squared is 2x, and so negative 2 times negative 2 is negative 4, and then x, so it is negative 4x. And then the derivative of 80x is 80 times of the derivative of x is 1, so it is plus 80. The derivative of negative 9, which is a constant, is 0. So we get negative 4x plus 80. We need to set this up equal to 0. So therefore, if we set this up equal to 0, we get negative 4x plus 80. This equals 0. Adding 4x to both sides, we get 4x equal to 80. Or otherwise, we can find x from this by dividing both sides by 4. And so we get x equals 80. So this is the number of watts to be needed to maximize the profit. We can verify that if at this value of x, this is maximum. For that, we have to find the second derivative of p of x, which is p double prime of x. So we find the derivative of the this expression negative 4x plus 80, which is negative 4. And this one, negative 4, is always less than 0, whether we replace this one or if we don't replace this one. So according to the second derivative test, when the second derivative of a function is negative, it means the function is maximum at this critical point. So therefore we see that at x equals 20, the profit is maximum. So we can see that 20 watts of ice cream are required to maximize the profit. To be sold to maximize profit. We now determine the maximum profit. So we have already understood that 20 watts of ice cream are required to be sold to maximize the profit. So at x equals 20, the profit is maximum, which means we can determine the maximum profit by plugging equals 20 into the profit function. So therefore we get P of 20, and this equals minus 2 times of 20 square plus 80 times of replace x by 20 minus 9. And so this gives minus 2 times of 20 square is 400 plus 80 times of 20 is 1600 minus 9. And this equals negative 2 times of 400 is negative 800 plus 1600 minus 9. So 1600 minus 800 is 800 and then minus 9. 800 minus 9 is 791. So the maximum profit is $791. We now determine the price to charge per watt to maximize the profit. So we are going to plug in x equals 20 into the price function so that we can determine the price such that the profit is maximum. So therefore we get P of 20, and this equals 82 minus 2x, replace x by 20. And so this gives 82 minus 2 times 20 is 40, and 82 minus 40 is 42, and this is in dollars. So the price to charge per watt is $42.